Hello, good morning. All are welcome for my basic electrical safety class. You may be knowing that I am Sadashivan, a fire and safety trainer. Last so many days I am coming in an alternate days. First I have given you some videos on general safety awareness. Then another 20 video I have given basic fire safety awareness. Now we have come to the electrical safety, basic electrical safety. There also I have given so many videos. Last class I have given some 15th video. What is electricity, electrical, this magnetism and electromagnetism. Today we are going to talk you about nearly next class what is AC and these types of load. What are the different types of load in AC system? Basic idea. So these things we are going to discuss on today's class. Okay, just before going to the class, I just want to have a request with you because this is a continuous education system I have planned for giving you not only for safety with basic fundamentals of electricity also you can understand it. So it is what is my request means you please try to see all the video continuously, and in case of any doubt you can also contact me. I have given the telephone number also, and moreover please request you please like it and share it and subscribe it. Okay, let us come to the subject. So what is AC and its types of load? What do you mean by AC? You know it, alternate current. How it is generating. This is the basic fundamentals must know it. And once it has generated, what are the type of loads in the system? That also you must be knowing. So basically, first to a few previous class, I have just mentioned the difference between AC and DC also. But AC generation also just the overall idea only I have just given you. Now we will go little bit theoretical knowledge. See, actually Faraday's laws of electromagnetic induction last class we have understood it. So based on that one, the AC generation is take place. Here you can see a generator, basic idea of generator. One permanent magnet is there, one north pole and south pole. This stator, the stator is having an electrical winding is there. Now, then this rotor, that north and south pole, that start rotating. Then what will happen? Some voltage will be generating. Then EMF, according to the Faraday's laws of electromagnetic induction, whenever a flux linked with the circuit, an EMF is induced in the circuit. So, if you are just rotating the magnetic field, that we get some voltage. That is in the shape you can sine wave like this way. So this is the way of electricity generation in all type of power sources, whether it is a hydro power station or it is a thermal power station or it is nuclear power station. That's why we are telling us Faraday is known as a father of electricity. And what is the magnitude of the induced EMF is the rate of change of flux linkage. So if you are more of speed you are cutting, more voltage will be there. So these are the basic knowledge which we have explained that class. Now that thing has come into the practical way like this way. Now what type of load? In the case of DC, you know that whatever may be the load, whether it is an inductor or a capacitor or a resistor, there is no variation, such variation is not taking place. Here what happens is, suppose our load is a resistive load. Resistive load means maybe one heater is there or any type of one simple gadgets and lamp is there. Then at that time, if you are giving a resistive load, what happening means the voltage and current, they are in phase with them. In phase means there is no any phase difference at all there. So that's why the power in the resistive load, we can say that V into I. There is 5 is the power factor is actually 1 there. So here voltage and current is in same phase. There is no any phase difference is there. But suppose next coming to the inductive load. Inductive load means most of our loads in our household items are inductive load. Even you are using a motor or even you are using a fan or this type of loads, some winding is there. That winding, that magnetic property is there. With this magnetic property we have studied that whenever any flux comes there, that opposing magnetic flux will be there. That is self-induction. So that because of that induction, what will happen means the watt plate voltage and current is not in the same phase. If it is a pure inductance means that practically it is not possible, but just imagine that if it is a pure inductance, the voltage and current is lagging 90 degree. That means first the voltage is coming there, then only the current will pass through the circuit. That means 90 degree lagging is there. But exactly it is not happening in 90 degree, because in inductive load, if you see that some resistance part will be there. So it is not exactly 90 degree, but it is less than 90 degree. So such type of load is the inductive type load. Here there is a phase difference. There is a phase difference in between current and voltage. That phase difference we are measuring, and that cosine of the factors, that phase difference angle is as a power factor. So that is inductive load. Now coming to the capacitive load. Capacitor we are learning. If you are just connecting the capacitor, what will happen means for that it will first taking a charge there. Then means current will be coming first there. Then only that voltage is coming. That means current is leading there. First current will be coming there. Then only the voltage is coming there. So here just opposite of the inductance. Inductance first voltage appear, and then after 90 degree the current will be coming. Here first current started coming, then only the voltage is appearing. That means 90 degree leading a capacitor. Here also practically not possible at all. Complete capacitor, some resistive part also be there. So now what we understood means, in case of inductive load, current always leading. In case of inductive load, current always lagging. Sorry. In the case of inductive load, current always lagging. In case of capacitive load, current always leading. That's why this capacitors we are using in many AC lines for a power factor improvement, because what we require means the power factor should be as a 1 only. Because what will happen if low power factor means that more kVA capacity of the generating station is required there in order to get an active load. So in order to get, but meaning depending upon the load condition, that power factor may be varying. As a simple example, suppose 1000 kVA load is there. That is if the power factor is 1, then what we can do means the same 1000 kilowatt is there. But if it is a power factor is 0.8, then what will happen means only 800 kilowatt only getting. 1000 there, previously we are getting 1000 kilowatt, that means 800 kilowatt only we are getting, but we have to produce 1000 kV also. So that difference is there. So you know, so for that purpose only, that power factor improvement we must do it. So this power factor improvement, how we are doing with the help of additional capacitors we are adding in the circuit. So that or there are some machines are there, synchronous motors are there, that's which the load itself is a capacitor type that we are adding in our system. So as far as possible, the power factor should be in unity. So this is the difference in AC and DC actually. DC we don't have botheration about the power factor, but in case of AC that power factor is there, that depends upon the load. So today what we have discussed is the basic principles of AC generation. A magnet is rotating in the stator inside the stator rotate, okay? And AC voltage is building up voltage. Now if you are given this voltage in the same resistive load, then what will happen is voltage and current is in the same phase. There is no any phase difference. That means the power is same as in a DC if a resistive load. But if it's an inductive load, what will happen means current will always be lag. That means first voltage will be coming there, then only current will be coming there. So there is a power, there is a difference, phase difference between current and voltage. Similarly, in case of a capacitive load, the voltage will come lagging and the current is coming first. So leading current, we can say that. So in order to improve the power factor, most of the loads are an inductive type load. In order to improve the power factor, what we are doing is we are giving additional capacitors in the circuit for improvement of power factor. So this is the basic idea of the AC. So now I hope that you got some idea about the AC generation and different type of AC load. Okay. For the time being, today I'm just stopping it. I will be coming with other subject on next class. I request you, if you like the class, please share it and subscribe it. Okay. Wishing all of you a good day, happy, healthy, and safe day. Thank you to everybody. Okay, thanks.